Alright, chemistry, this is another sample problem coming at you from chapter 7, section 3. In this sample problem, we're going to be calculating the percent composition of sodium nitrate, NaNO3. Now, one of the things we're going to need to do first off is calculate the molar mass of NaNO3. Now, the nice thing about calculating percent composition is it doesn't matter how much of the sample we have. It just matters that we pick a simple value to start with. So if we just pick 1 mole, if we just assume there's 1 mole, we can calculate the percent of 1 mole. There's nothing special about that 1 mole figure except for the fact that it's very simple to work with. It's very easy to work with. But we could also pick numbers like 59 moles, and we could still generate the same percentages. It would be just a little less intuitive on the math side. We're going to calculate the molar mass of sodium nitrate. Again, I'm going to list each element that appears in the substance. I'm going to look at my periodic table. Again, you should have this out whenever you're working these types of problems. And I'm going to find the average mass of each of the species I've listed here. So sodium comes in at 22.99. Nitrogen comes in at 14.007, and oxygen comes in at 16.00. Next, for 1 mole of this substance, take into account how many moles of each individual element are present. There is 1 mole of sodium, there is 1 mole of nitrogen, and there are 3 moles of oxygen. This math works out to be pretty easy. I'm going to calculate how much mass is due to each individual element here. Now the nice thing about doing this problem using this procedure is later when I go to calculate the percent composition for each individual species, I actually have the total mass due to each individual element already listed and easily accessible. So I definitely suggest using this procedure in the future. Alright, next up, I'm going to use my calculator to make it a little bit easier on myself. I'm going to add 22.99, 14.007, and 48.00. My calculator tells me that is 84.997. Alright, we're we're definitely in the mode of checking our significant figures. We're doing addition, so we check the number of digits to the right of the decimal. I see that this value has 2 digits past the decimal, this has 3 digits past the decimal, and this has 2 digits past the decimal. And so my answer needs to also have 2 digits past the decimal. So I will not use 84.997 for the mass of my overall substance. I will use, again, this is going to have to round that up, which will round that up, which will round that up. I'm going to use 85.00 grams for this entire substance. So if I have 85.00 grams, again, that's 1 mole, right? That is the molar mass. If I have 85 grams of this, what percentage of that 85 grams is nitrogen? What percentage of that 85 grams is sodium? Did I say nitrogen before? And then what percentage of this 85 grams is oxygen? All right, so I'll set up 3 more calculations. I'll go 22.99 divided by 85.00. Both of those are in grams. I'll set up 14.007 grams divided by 85.00 grams. And then lastly, I'll set up 48.00 divided by 85.00. Both of those are grams. Now notice that on all of these calculations, the grams are actually going to cancel, and so I'll get a unitless decimal, and it should be less than 1. I'll take that decimal, multiply it by 100%, and that will be the percent composition of sodium nitrate. Alright, so let's punch this in the calculator. 22.99 divided by 85.00. Go with 0.27. Again, I need to use 4 significant figures, or 0.2705 times 100%. It ends up being 27.05% sodium. Moving on to nitrogen, go 40.007 divided by 85.00 again. It's coming up to be 16.4. I'm actually going to round just off the fly because I knew I need to have 4 significant figures. So I'll have 4 significant figures multiplied by 100%. I'll have 16.48% nitrogen. Now just looking at these two values that I've already calculated, 27.05 and 16.48, I can already get an idea of what the percent due to oxygen is going to need to be. It's going to need to be around 55 or 56 in order to make up for the percentages that I'm missing here, because again, all 3 of these percentages have to add up to 100. All right, there's between 100 and these two numbers are going to be somewhere around 56 off the top of my head. All right, so let's look at oxygen and see if it fills in as we predicted. We got 48.00. We're going to divide by 85.00. That comes out to be 0.5647. We're going to multiply that by 100 to be 56.47. And lo and behold, it actually does match up with our prediction so that all 3 of these percentages added together will equal 100%. So the percent composition of sodium nitrate is 27.05% sodium, 16.48% nitrogen, and 56.47% oxygen.